Hi students, in today's video we'll be studying how to diagnose acid and bases disorder. Okay, so you know acidosis and alkalosis is an important chapter and it's covered in competency 6.8. Over here you can see BI 6.8. You all know by now what's the MCI competency for biochemistry. So it says discuss and interpret the results of arterial blood gas analysis in various disorders. Okay, so we'll be right away jump into the topic, and by the end of this class I will make you a master in diagnosing ABGs. All right, so first and foremost, before going to the actual discussion, you should know all this. This is the holy grail and bible of any acid base problem and disorder. Okay, you already know this. This is nothing but Henderson Hasselbach equation. Remember the spelling Henderson. It is not Henderson, not HA. Okay, that's the area where most student does the mistake, and Hasselbach has L silent. Okay, so remember Henderson Hasselbach equation. It says pH equals to pKa plus log of concentration of base by acid or salt by acid, and if the numerator and denominator is equal, then log 1 becomes 0, then pH becomes pKa. Okay, this is the basic equation that all of us needs to know. Why? Because you know in Viva, if you fail to answer any question related to acid and base disorders, the last question which you must know in order to pass is this. Examiner will then ask you, fine, whatever, forgive me, just tell me Henderson Hasselbach equation and go. If you make a mistake over there, then you will of course go to come back after 3 months for the supplementary examination. So that being said, we should know what's the normal range of pH and when will we call a case acidosis or alkalosis. All right, so the normal pH, the homeostatic range is 7.35 to 7.45. okay, beyond that, above 7.45 is the alkalosis and below 7.35 it's acidosis. Okay, now it goes beyond doubt in saying that when there is acidosis, it means pH will drop, it means acid will increase, it means there will be excess concentration of hydrogen ion or proton or H plus. Now how H plus can increase? Number one, by accumulation of acid, okay, or by loss of bases or the balancing anion. So over here you can see acidosis means increase in H plus. Remember H plus is inversely proportional to pH. So it means when H plus goes up, pH will go down. So acidosis is lowering of pH. How it can happen? Excess accumulation of H plus or loss of OH minus or bases. However, the reverse happens during alkalosis. So in alkalosis there will be rise in pH due to low or lowering of H plus. So how H plus can be lowered? Number one, loss of acid or excess alkalis or accumulation of bases. So this is the basic principle and homeostasis of acidosis and alkalosis that you need to know. All right, now in today's video I am taking it for granted that you already know the basics of acidosis and alkalosis. Okay, so regarding symptoms of acidosis and alkalosis, we will not be discussing them in today's class. Okay, what we will be doing, we will be diagnosing acid base disorders. I will be telling you what are the diagnostic criteria, what are the treatment, that also I will tell you. But if you want to know the symptom of all the acid base disorder, it's better to revise your textbook because all of the acid base disorder will come as a short note. So metabolic acidosis, metabolic alkalosis, respiratory acidosis and respiratory alkalosis will come as a short note, and you need to mention the clinical features also. They are not very difficult, but they are useless when diagnosing problems of acidosis and alkalosis and ABGs. with respect to first professional MBBS student. Okay, so the first step that we need to do is, number one, to diagnose whether the disorder is acidosis or alkalosis. Alright, so whether the pH is low or pH is high, that you need to identify. Over here, this is the passing area, must know. If you fail to diagnose whether the disease is acidosis or alkalosis, you are failing, guaranteed. Okay, next, so for them we need to know the normal values of partial pressure of carbon dioxide, we need to know the normal value of pH, potential of hydrogen, and we also need to know the normal value of bicarbonate ion. Okay, these are the three key ingredients whose normal values we need to know. If we know this, we can definitely diagnose a problem. So as a rule, the second part of the problem, first is to diagnose whether it's acidosis or alkalosis. The second part, which is also must know area, and that's enough to get you pass, is to diagnose whether the disorder is metabolic or respiratory. Alright, so common sense, respiratory, lungs, they deal with carbon dioxide. Okay, so whenever any acid base disorder is caused due to change or shifting of a value in partial pressure of carbon dioxide, PCO2, the problem is always respiratory. If you can remember one, you will remember the other. It means any problem in bicarbonate or any value or shifting in HCO3 minus, which is causing the acid base disorder, it's metabolic. Get my point? So number one, you need to diagnose acidosis or alkalosis, and number two, whether it's respiratory or metabolic. And lastly, not a must know area, but you should know this, is how you can diagnose whether this disorder is compensated or not. Okay, I'll teach you how to diagnose whether it's compensated or not. So as a basic formula, what you can do is look at the value of pH or look at the value of the parameter that doesn't correspond to the observed pH change. For example, I'll be again telling you this, bicarbonate. Okay, so bicarbonate is an alkali. So if alkali goes high, pH should also go high, so it should be alkalosis. However, in a problem you are seeing that pH is low, it is an acidosis disorder, but bicarbonate is still going up. It means this is not a direct causative reason factor, it's a compensatory factor. Okay, so in compensation what happens, because of the disease the parameter is changing, but as a causative factor, because the parameter is changing, the disease is occurring. You get my point? If this is due to primary or originally metabolic disorder, then if bicarbonate value goes high, what will happen? It will lead to alkalosis. But if it is a compensation, it means acids are high and bicarbonate is going up to compensate the acidosis. Okay, it may appear confusing, but just remember this, just look at the value that doesn't correspond to the observed pH change. So if bicarbonate goes high, for example, and pH goes high, direct cause, so this is primary. If bicarbonate goes high, pH is going in the opposite direction, so directly not corresponding, it is a compensatory change. Similarly, values in PCO2 will also go high and go low depending on the whether it is primary or a compensatory change. Okay, so if it is going outside the normal range, the body is partially compensating the problem. So other than diagnosing whether the disorder is compensated or not, the next step is telling whether the disease is fully or partially compensated. Okay, so there are 4 levels in doing this as a basic problem diagnosis. First, acidosis or alkalosis. Next, metabolic acidosis or metabolic alkalosis, respiratory acidosis or respiratory alkalosis. Next, whether it is compensated or not, and next, whether the compensation is full or partial. Mind it as a must know area. If you can diagnose the first two, the primary respiratory metabolic disorder, it's enough to get you pass. So the rule of compensation is always occurring by the other system. For example, if there is a respiratory disorder, the compensation will always happen by a metabolic pathway. And if there is a metabolic disorder, the compensation will always happen with the help of lungs. So you see, if the underlying problem is metabolic, that is problem in bicarbonate, then hypoventilation or hyperventilation can help, means it is getting compensated by lung. Metabolic problem will be compensated by respiratory, and if the problem is respiratory, then kidney will play a role and it will help in compensation, therefore metabolic compensation. So as a rule, if you diagnose a disorder to be respiratory acidosis, remember the compensation will always be in a metabolic, okay, and if you diagnose a disorder to be metabolic alkalosis, the compensation will always be respiratory. So first let us briefly see how to diagnose the disorders, and then we will go into the problems, okay. So respiratory acidosis, in this chapter, okay, in this lecture, you don't focus on the conditions, okay, forget them. I'll tell you why. You only need to look at the value. So respiratory acidosis will only claim a problem to respiratory acidosis if the levels of PCO2 are above 45 millimeter of mercury. So this is levels of CO2, means it will be represented as PCO2 or partial pressure of carbon dioxide. Get my point? Just remember this only from this slide. It's caused by hypercapnia, which means high levels of carbon dioxide in the blood. As you know, how respiratory disorder will be compensated? It will be compensated by metabolic pathway. So kidneys will eliminate hydrogen ion. Forget how kidneys are doing it. Just remember, kidneys are doing it. Okay. Of course, it will eliminate hydrogen, it will eliminate the excess acid, and it will try to regain alkali. This is how it will be compensated. Remember, compensation and treatment are not the same. Compensation means body is trying to control it, but the treatment, when we need treatment, when the body has tried and it has failed, then only it can be treated. So the treatment of respiratory acidosis is by IV lactate solution. If you are to tell only one, just remember, treatment of all acidotic disorder are IV lactate solution. Okay. Bus. Now let's go to the next slide. So one and only one thing to remember in case of respiratory acidosis, PCO2 above 45. Okay. And treatment of respiratory acidosis is by IV lactate. Remember, compensation is by metabolic. Don't confuse compensation with treatment. So going on to the next one, respiratory alkalosis. So again, since it is respiratory, there is problem in PCO2. So any problem in PCO2, the diagnosis will be respiratory. Now if PCO2 goes high, it will be acidosis, because PCO2 dissolves in water to make carbonic acid. Therefore PCO2 level, if the opposite happens, if it goes down, there will be alkalosis. So remember, PCO2 level is inversely proportional to the pH. Get my point? So if PCO2 goes high, means excess acid, pH will go low, and if PCO2 goes low, then the pH disorder will be alkalosis. So if PCO2 less than 35, it is respiratory alkalosis. Just one thing to remember from this slide, nothing else. Okay. So what will be the compensation? By now we know respiratory disorders will be compensated by metabolic pathway. So kidneys, what will kidneys do? Since there is excess alkali, it will try to conserve hydrogen ion and excrete excess alkali. Remember how compensation and treatment are different. So treatment of all acidosis was by IV lactate. Treatment of respiratory alkalosis is by IV chloride. Okay. Chloride actually replaces lost bicarbonate ions. The mechanism you don't need to know. These things are all basic precautions. If you don't have access to saline, then breathing into a paper bag, etc. Remember, acidosis treatment by lactate, alkalosis treatment by chloride, not compensation. Compensation is what the body does. Treatment is what you and me we will do as a physician. Alright. Next, we move on to the next metabolic disorder or next acid base disorder, that is acidosis. Now it's metabolic acidosis. Now any metabolic disorder means we will have no relation with PCO2. Now the problem is with bicarbonate, because bicarbonate is the key factor that determines whether the disorder is metabolic or not. Excuse me. So we saw the value of PCO2 was inversely proportional with pH. However, the level of HCO3 minus is directly proportional to the pH. What does it mean? If HCO3 minus goes low, pH will also low. It means acidosis. If HCO3 minus is high, above the normal range, pH will go high. It will mean alkalosis. So remember, PCO2 inversely proportional, bicarbonate directly proportional. Fine. So what will happen? Since we are talking about acidosis means and metabolic means always bicarbonate, and acidosis means pH will go low, so bicarbonate will also low. So low than what? Lower than 22 milli equivalent per liter. Okay, just one thing to remember from this slide. When you are to diagnose acid base disorder, just remember bicarbonate below 22 MEQ per liter means metabolic acidosis. Now next question, how a metabolic acidosis will be compensated, or any metabolic disorder for that matter will be compensated by respiratory. So just ask yourself what will happen. Now there is acidosis, means excess acid. So how lung can compensate? Lung will try to remove excess carbon dioxide. Excess carbon dioxide means acid. Lung is now trying to make the situation alkaline. So there will be increased ventilation, there will be wash out of CO2. Alright, just only one line, forget them. You don't mention this at all, even if it's written in your textbook. That's why I have included this in this slide and deliberately I am striking it off. Metabolic disorder for your level will always be compensated only and only by lung. So respiratory compensation by increased ventilation. Now if you are treating the disorder, all acidosis are treated by lactate. Formula is the same. When you are treating, we don't see whether it is respiratory or metabolic, we just treat the pH value. So acidosis means pH is low, we need to shoot it up. So we always provide IV lactate solution. Okay. So remember, for diagnosing metabolic acidosis, bicarbonate below 22 MEQ per liter. And the last but not the least, metabolic alkalosis. So one thing you need to remember from this slide is bicarbonate above 26 MEQ per liter, milli equivalent per liter. Okay. Remember, I am not reading out all these because I told you already, basic acidosis and alkalosis should be clear before you are seeing this video. So causes of the acid base disorder, what are the symptoms of acid base disorder, and the treatment, all of them will constitute the short note. So if each of these come as a short note, you need to mention all of them. However, these are nothing to understand, you just simply need to memorize them, ratify. So you can simply pause the video and take the note, or you can go through your textbook, but the only thing you need to understand in order to diagnose an acid base disorder problem is that in case of metabolic alkalosis, problem will be with bicarbonate because it is metabolic, and the cutoff mark is 26 MEQ per liter. I ask you how a metabolic disorder will be compensated, of course by respiratory. Now it's alkalosis, lung will try to increase acid. So what will happen? Lung will try to retain the carbon dioxide. It will try to compensate the disorder by hypoventilation. Okay. Yes, alkalosis is mostly common with renal dysfunction, so can't count on kidneys. It means what? A metabolic disorder cannot be compensated by a metabolic pathway. So kidneys will not help. Who will help? Lung, by hypoventilation. In hypoventilation, what will happen? CO2 level will rise. CO2 level rise means excess acid, and that can compensate the alkalosis situation. I told you all acidosis are treated by lactate and all alkalosis are treated by IV chloride. So remember this one thing you need to remember: in case of treatment, not compensation. Compensation always occurs in the body and it's by the opposite pathway. But treatment, as a doctor, we need to treat the pH, that is high pH is treated by IV lactate solution. Okay. So again, let us revise. So first you need to see whether the pH is high or low. pH low means acidosis, pH high alkalosis. Then you need to look at the values of PCO2 and bicarbonate. PCO2 abnormality, respiratory; bicarbonate abnormality, metabolic. So they will be compensated in the reverse phenomena, in the reverse pathway. So if pH value is causing the acid base disorder, it's respiratory disorder primary. If the bicarbonate value is causing the acid base disorder, it's metabolic. However, if the bicarbonate value is not causing, or it is going in an opposite direction, it is a compensatory mechanism. And what happens if the pH value is almost near to the normal level? Then a disease is fully compensated. There will be still abnormalities in the value of bicarbonate and PCO2. However, if the pH is near normal, it means what? The disease happened and the compensatory mechanism triggered and they are fighting to bring the pH back to normal. So if the pH is not near normal, then there is no compensation. If the counter factor is going up or down, it is compensated, and if the pH is near normal, it is fully compensated. I will give you practical examples to show you, and you will be able to diagnose it. So remember, compensation: a respiratory disorder will be compensated by metabolic, and a metabolic disorder will be compensated by respiratory pathway. So before going into the chapter or the problems, you should know the normal values by heart them. Okay, you will not be given normal range in questions. So in questions there will be direct values. So first you need to identify whether those are high, low or normal. If you fail to do that, you are gone. So remember, pH 7.35 to 7.45, pH has no unit. Bicarb PCO2 35 to 45, in few textbook it may be 36 to 44 depending on them, but if it's 35 to 45, consider it normal. Okay, unit is millimeter of mercury. Fine. Bicarbonate 22 to 26 MEQ per liter, milliequivalent per liter. Okay, anion gap and albumin are a part of advanced acid base problems which is not needed for undergraduate. However, if some of you are highly interested to know that, remember anion gap will come as a short note. Okay, fine. However, in complex problems, or if you are a PG student and you are watching this, or your friends and brothers, seniors or roommates are PG student, then they must be facing some problems in the NEET PG exam, where they will also be asked to find out what is the anion gap, what is the delta gap, whether the disorder is high anion gap or normal anion gap. Then we need some extra steps. Those are not needed for undergraduate students, so I am skipping them in this video. But if you are interested, please let me know. I will surely make a follow-up video to this one. So what's the primary disorder? What you need to do? Don't see this. Okay, for you it's step 1. So step 1 is diagnosing whether the disorder was acidosis or alkalosis. Fine. Now remember this flow chart. So in case of respiratory acidosis, don't see this, just ask yourself what will happen. Since it's respiratory, therefore there will be, okay, first acidosis. Acidosis means pH will be low. So acidosis, pH low. Alkalosis, pH high. Alkalosis, pH high. no doubt about that. Now, respiratory acidosis, so there will be problem in PCO2. How PCO2 is related to pH? It's inversely related. So since pH is going down, PCO2 has to go up because it's an acid high, pH low. Metabolic acidosis, problem in bicarbonate. How bicarbonate is related to pH? It's directly related. So pH low, bicarbonate is also low. Respiratory alkalosis, alkalosis means pH high. How PCO2 is related? Inverse way. So pH is going up, PCO2 will go down. And lastly, metabolic alkalosis, both will go high. Clear? Remember this one. So with these two slides, you are now almost ready to diagnose an acid base disorder. Okay. Again, if you are okay with this slide, then I would suggest to pause this video and copy this slide also. Why? I'll tell you why. This slide also tells you about the compensation. Over here, see. So first, see, pH low means acidosis. It is due to PCO2. Therefore, it's respiratory acidosis. Bicarbonate level is normal, means there is no compensation. So it's plain and simple respiratory acidosis. Okay. Over here, see, pH is high, so alkalosis. PCO2 is low. It's caused by, so bicarbonate level is normal. It's caused by respiratory, so respiratory alkalosis. Okay. This means no compensation. Okay. So it's simple respiratory alkalosis. Next, look at this problem. If pH is low, means again acidosis, PCO2 normal but bicarbonate low, means metabolic acidosis. It should be very clear. Next, pH is high, PCO2 normal, no respiratory component, and pH and bicarbonate is also high, so it is metabolic alkalosis. So these four is nothing but repetition of this slide. Get my point? Remember, in your exam, problems will not be given like this. It will not say high or low. There will be a value, and for that you need to remember this slide. Okay, the normal values. Now let us deal with some compensations. This is interesting. Now see, there are two problems of compensation. See this one. So first, as a step one, you need to see whether it is acidosis or alkalosis. pH low, acidosis. So this is acidosis, no doubt about it. Now, acidosis can be caused by either change in PCO2 or change in bicarbonate. Now, if this is caused by bicarbonate, then bicarbonate will also go in the same direction, and if it is caused by PCO2, PCO2 will go in the opposite direction. Remember? So over here we can see the PCO2 is going in an opposite direction, so excess acid and pH is also low. So this is the causative disorder, so it is primary, 1 degree. This is the primary. And what is this? Bicarbonate is also going up. If it was due to problem in bicarbonate, if that was a metabolic component, then bicarbonate should have gone down, isn't it so? Just think, just close your eyes, pause this video and think. If bicarbonate was causing this, then excess high in bicarbonate would have increased the pH, but this is not so. Bicarbonate is going in an opposite direction, therefore it is a compensation. So what bicarbonate is doing here? Bicarbonate is trying to compensate the excess acid by going up. So this is respiratory acidosis with metabolic compensation. It may be a bit difficult, but just rewind this video 2 minutes and then again go through it. Next, see this, pH high, alkalosis, no doubt about it. Now we look at the values of PCO2 and bicarbonate. As I told you, if it is caused by metabolic disorder, both bicarbonate and pH will go in the same direction. If it is caused by respiratory disorder, PCO2 and pH will go in a reverse direction. Over here we see bicarbonate and pH are going in same direction. It means it is caused by metabolic. The disorder is metabolic alkalosis. And what lung is doing? Lung is actually trying to compensate by increasing acid so that it can compensate the alkalosis. So it is respiratory compensation. Clear? Now there will be few problems which will try to confuse you. See over there. See over here, the pH is low, so it is due to acidosis, no doubt about it. Now let us see how the changes are occurring. pH, bicarbonate is low and PCO2 is high. So who is causing and who is the compensator? There is nobody. So both lung and both the kidneys are making this disorder happen. So if that is the problem, means you can see bicarbonate is going in the same direction as pH and pH is going and PCO2 is going in the same direction as pH. Then it is a mixed disorder. When a mixed disorder is given, it's a tough question and you are expected not to do the right thing. The examiner take it for granted the students will do mistake. So if you make a mistake, just keep your basics right. But remember, if you can diagnose a mixed acid base disorder, you are a champ. So this is a case of mixed respiratory metabolic acidosis. The reverse thing can also happen. So pH is high alkalosis and it is caused by both PCO2 and bicarbonate. So mixed respiratory and metabolic alkalosis. Clear? If this is clear by now, then you should write the code of the day in the comment, okay, to make me feel satisfied that you have understood. The code of the day is this one: balance. Balance you should write in the comment section and I will know that you have understood. So let us now go into the problems. See, all acid base disorders will have a huge history, okay. If you are in a hurry, see, there are clues, okay. If you know what are the causes of acidosis, what are the causes of alkalosis, there are many clues in this disorder. For example, nasogastric tube, suction, draining, etc. But as a hack, as a shortcut, I will tell you, don't look at them. In case of any acid base disorder, what I always tell my students, stop looking at the history, okay, just look at the parameters. So for your convenience, I have given the normal values over here, but they will not be given in exam, okay. Remember, this is 36 to 44, right, and this is 22 to 26. So a mean value is given over here. Now ask yourself, what is this? Okay, before I explain, pause this video and diagnose this and let's see if your answer is correct or not. I may be wrong, your answer may be wrong, but if you can make the examiner understand the logic why you are trying to diagnose, you will be given marks, alright, provided your logic is right, okay. So this is alkalosis, 7.5, pH high, above normal. Now we look at the parameters. So PCO2 is perfectly normal, so no respiratory component, and bicarbonate is high, so it is what? Metabolic alkalosis. Is there any compensation? No compensation, because PCO2 value is absolutely normal. Fine. So move on to the next problem. Another big history. Don't look at them, simply ignore, okay. Remember, if its value, now see, this is 7.15, so this is acidosis, no doubt about it. Again, write this problem down and then see whether your answer is right or not. PCO2 excess high, so PCO2 going up, pH going down, respiratory acidosis. What bicarbonate is doing? Bicarbonate is normal, okay. So it's respiratory acidosis and no compensation. Am I clear? There is no compensation from any metabolic component, but purely due to respiratory problem, okay. Next, Forget the history, case history, look at the parameter. pH, it's high, so alkalosis. Fine. PCO2, 21, low. Bicarbonate, 19, low. So if you can think logically, the answer is there. If you are forgetting everything, you can go back to this or this chart. Okay, but I will suggest you not to go by this up down method, but just think on your own. So what is the actual thing happening over here? 7.58 alkalosis. So who is causing this alkalosis? It can be either caused by the lung or it can be caused by the kidneys. Now let's see, PCO2 can cause alkalosis by going down. It is inversely related to the pH because pH is going up over here. You see, pH is going up. Now PCO2 is going down, and what bicarbonate is doing? Bicarbonate is also going down. So certainly this bicarbonate has not caused this one, it is caused by PCO2. So we are giving a star over here. So the primary disorder is respiratory alkalosis with metabolic compensation. I believe most of you and all of you got it right. If not, you will get it right. Okay. This problem has got a small history. Okay, so let's see what's happening over here. pH 7.3. So normal pH range is 7.45, 7.35 to 7.45. So if it's 7.30, definitely it's acidosis. Okay. Now let's see who's causing this acidosis. Bicarbonate 20. So bicarbonate is low. pH is low, mind it. And what's PCO2 doing? PCO2 is also low. So I give you 5 seconds to diagnose this. 5, 4, 3, 2, 1. pH low, acidosis. Who is causing this? PCO2 is inversely related, so it is not causing. Bicarbonate is directly related, so it is caused by bicarbonate. So metabolic acidosis. So what's the reason PCO2 is low? It's compensating. So metabolic alkalosis, metabolic acidosis with respiratory compensation. So remember, this is not over, because as I told you, there is another advanced version of this video that I'll be doing, where I'll be showing you how to check anion gap, how to check delta gap, but that is not required. That is not a must know area. Only if you're interested, please let me know in the comment and I will make that video for sure. Now let us revise what all we studied in this video. This is competency number 6.8, 7.35 to 7.45. This is the normal range, and this can be caused by excess acid. pH low can be caused by excess acid or less base. The reverse can be caused by less base and excess, less acid and excess base. Okay, don't get confused. So how to diagnose? We already told you, we went through all the each and every acid base disorder, but one thing to know that acidosis is treated, not compensated, treated by lactate, and all alkaloses are treated by chloride. Okay, so moving on, I told you, you need to diagnose the acid base disorder first. We look into the primary phenomena, who is causing, and look into the secondary phenomena, who is related to it and who is trying to compensate. And the formula is respiratory disorder will be compensated by metabolic and metabolic will be compensated by respiratory. That being said, we looked into the normal values, and the normal values of the first three are must to remember: pH, PCO2 and bicarbonate. And then we looked into various combinations, and I told you pH is directly related to bicarbonate level and pH is inversely related to the PCO2 level. Okay, and then we went to the problems, and I hope by now you are a master of all acid base disorder. So feel free to get back to me with any problem. Just mention the time and mention your query in the comment section. So I hope this was very easy for you, and you can look into your problems of acid base disorder in your textbook, and I'm sure you will be easily able to solve them now. So bye and take care.